Hello all. In this video we're going to take a look at the MazePlanner program, which I've written for you all to use. It's based on some things you can find online. There are similar apps that are written for running online with a similar kind of a world. But this one implements some of the search algorithms that we're looking for or looking at, but it also has some gaps where you will be filling in the details. So I'm just going to look at it not from the code side for now, just from how you can use this to explore how these algorithms work. So I'm going to start by explaining the left side of the application, which is the maze editing portion. And then we will take a look at the search separately. Essentially, you can either be editing a maze with the tools on the left, or you can be running through a search algorithm with the tools on the right. And when you have one enabled, the other is disabled, and vice versa. All right, so let's look at these options that we have on the left side. There is a possibility that you can load and save mazes. It will provide you with some. In our GitHub repo, there will be some mazes to start with that you could load. You can also create a maze, and if you like it, save it if you wish. When you have a maze created, you can move things around if you like. So right now, this is the changes you can make to the maze are marked right here. You can add or delete blocks, you can move the start, you can move the goal, you can increase the cost at a cell or decrease it. So let me explain what is actually in the grid right now. This is, I think, a 20 by 20 grid, and you can see that each cell is shaded with various shades of gray. These correspond to the weights. So this is a terrain world. So the darker cells are more expensive for the agent to move through. We can't actually see the numbers here. I've thought about adding that into the program, but you can just, as you're visualizing it, you can tell from the color. If you really want to see what the costs are, save the maze. It saves in a text format, and you can actually pull it up and take a look. There are a couple of special locations here. There is the goal location, which is shown with a green box around this cell itself, and then the goal is the red box. Right now I've got it set to move start, so if I click in other locations, the green box moves around with me. That's changing what the initial state is. You can actually click and drag if you want, and it will do that. It's just fine. The default is that we put them as far away as they can get from each other, so it's typically the upper left corner and the lower right, but there's no reason you have to leave it that way. You could, in fact, move the start or the goal around. Uh-oh, now I've gotten rid of the goal, so I could cause this to crash. Let's move the goal and place it right there. So I can select up that I want to move the start or goal. I can also do things like increasing the cost. So maybe I want this cell right here to be more expensive. So I just click in that cell and you can see it gets darker. You can do the same thing clicking and dragging if you want. If you switch to decrease cost, then you can click and drag to decrease the costs as well. Either way is doable. The other thing you can do, if you select add or delete blocks, you can click on a cell and notice it shows up in this kind of a garish teal color. Those are obstacle blocks. The agent cannot pass through those. So it allows us to build maze-like environments, or to build weighted environments, or to build things that are a combination of the two. I'm actually going to remove these for right now because I don't need them right now. All right, so you can edit the maze as you wish. If you don't like the configuration that it has initially, you can also have it generate new random mazes for you. So I could say that I want a new hilly maze. A hilly maze is a terrain maze, or it's a terrain world. And so if I click on this, you'll see that it just generates new random terrain worlds. If I want a world that doesn't have weighted squares, I can do that as well. I can make a new flat world. The default is that we have no cost at all, so the cost is like 1 everywhere. If you want there to be obstacles in this world, you have to change this percentage. So I could say 25. That's the percentage of the grid that will be obstacles, and that looks perfectly fine. That's about a quarter of the grid is filled, but otherwise it's open. And again, you can edit this as you wish. All right, what I'm going to do next is to start talking about the search options. So over here on the right, you can see that there are a number of search options. I will tell you, not that many of them are actually implemented in the code I'm providing, because you are going to be the one implementing them. What we do have implemented right now is the lowest cost search, which in this environment where all the cells have the same cost, it devolves into breadth first search. We also have greedy best first search, which devolves into depth first search essentially. And we have, in this particular version, we have A star search. We do not have Dijkstra's as a separate thing, and these others are ones that students implement when they work with this code. So suppose that I actually want to try out breadth first search on this maze, this grid world that I've made. What I would do is select it and then click Setup Search. And you see that I've got step search, run search, and quit search. When you quit searching, then the edit options will be re-enabled, and you'll have to start a whole new search over from the start. If you step through the search, then it's going to look a lot like the example that I walked through in a previous video. It's going to show you step by step what's the fringe, what's the selected node, what's actually happening with the search. So in this case, the fringe elements, the frontier elements, are the light blue, and the current cell is hot magenta, and explored cells are marked in red. So I'll just keep stepping. And you can see it's checking, it's kind of moving it outward fairly evenly, except obviously where there are obstacles in the way. I'm going to run it. Let's just see what it looks like. Whoa. That was pretty fast. With a 20 by 20, you can actually step through this pretty well. I'm wondering if there's a bug in here right now, because it should not have done that. But you can see how it's almost like that ripple in the pond effect that we were talking about before. It's spreading out evenly in all directions. You can see that especially, I'm going to quit the search. If I run it, it'll just show us the best path. You can see that it actually visited essentially everything in the space. Everything's been explored. I'm going to quit this search. I'm going to try making a bigger map. So let's make one that's 50 by 50. And again, with about 25% obstacles. Actually, I want fewer. Let's make this 10% obstacles. Okay. I'm going to move the start to the middle of this space, more or less. And then we're going to set up the search and run it there. Because what you'll see is definitely an expanding outward ripple until it has explored the entire space. And this is the goal is fairly far away, so it does in fact explore the entire space. All right, so what happens if we do hilly worlds instead? Ooh, I don't know if I want a hilly world that's 50-50, and I don't want 10% obstacles. So I'm going to change this back to, let's try something slightly bigger than the one we started with. Let's do 30 by 30. All right, ooh, I don't like that start location because it's already in an expensive place. So I'll move it to a slightly less expensive place, fairly close to the same. And now when we're running this will be running lowest cost first. So you'll see that it'll have a preference for going around the expensive areas. It will explore the valleys first, and it will explore in the other regions as well as the cost grows. So let's set it up, and we'll take steps to see what it's going to do. So there you can see it kind of is spreading out in the lower areas, comes back and expands the others a little bit as things get expensive. I might set this to do, let's say, 8 steps at a time. Hasn't really found an inexpensive way through, so it's just spreading out more like breadth first search. Oh, and then it found an inexpensive way at the top. And it's gradually getting closer to the goal. And there, it's found the best possible solution. So we'll look at A-star in a different video when we are talking about that, but this gives you just a sense of how you can use this to visualize breadth first search. I want to show you depth first search as well. All right, we're going to stop there. We'll come back with this. You will have a chance in class to play with this piece of software. This is a fairly simple program, and that's also kind of on purpose because it's a good test bed, but it also lets you actually dig into the code, figure out how it works, and make it better. So I look forward to watching you experience that when we're in class. All right, I am going to stop there. We've taken a look at a visualization program. You can find other ones online that are also really interesting, and I encourage you to do some research that way. Otherwise, I will see you very soon.